Learning how to declare, define, and manipulate variables is a crucial part of programming. Variables allow you to store data and change that data during runtime. But before we discuss variables, let's talk about literals. A literal is simply a fixed value that does not change throughout the program. For example, when we specify the pin number for digital write in our Blink example, we're using the literal 13, which is an integer. It's considered a literal because the number 13 won't change while running our program. Other literals include the floating point type, which can be in decimal form, or scientific notation where the number after the e is the exponent part. So this would become 1.602 times 10 raised to the negative 19th power. Additionally, literals can be a single character, or a collection of characters known as a string. Sometimes you'll find the Boolean phrases true and false as literals. We just covered some of the data types for C. Literals and variables can be one of a few types. First, there's void, which means no value. You will generally see this in function definitions to show that the function has no return type or no parameters as inputs. Then there are integers, which are abbreviated as int. The basic integer takes up 2 bytes in Arduino memory and, as such, can be a number between negative 32,768 to 32,767. Floating point numbers are abbreviated as float and can take up 4 bytes of memory, which means you can have numbers between about negative 3.4 times 10 to the 38 and positive 3.4 times 10 to the 38. Character is shortened to its first 4 letters and is often pronounced char or char. Characters are stored as a 1-byte number. That means only 256 possible characters are available for us in the char type. Characters are stored as numbers in the ASCII format, the American Standard Code for Information Interchange, which was created in the 1960s. With it, we are able to store capital and lowercase English letters, numbers, and various punctuation marks and symbols. Unfortunately, it is much more limited than other modern encoding schemes, but it doesn't take up a lot of memory to store a character. Other types exist, but those are the primary 4 that we need to know about. We'll talk about the other types as we come across them. Even Boolean isn't an original C data type, but it will work in Arduino, and we can declare one as bool or boolean. For now, let's discuss how data types apply to variables. A variable is a storage location paired with a symbolic name, often called a reference or a label. It might help to think about a variable as a type of container. Here I've got 2 cups. The first cup is labeled A and is of type int. The second cup is labeled B and is of type char. I would not, for example, be able to store the number 3 in the char container. However, I can store it in the integer container. And I can store the letter y in the char container, but not in the integer container. Whenever I reference a variable, say A, I would be given my number 3. And if I reference B, I would be given the character y. I can swap out the values in a variable, for example, replacing 3 with the number 42. But a variable can only contain one value at a time. Let's see how to make and use variables in code. Open up the Blink example. Instead of writing 13 3 different times in our code to refer to the same pin, we could use a variable. First, we want to declare the variable, so write int LED. That is, we tell the compiler that we want to reserve a section of memory to store a value with the given data type. In other words, we create our container. Notice that we're doing this outside of the setup and loop functions. This will allow both setup and loop to access the variable and is known as global scope, which we'll discuss later. Also, note that variable names may only contain letters, numbers, and underscores. So, my underscore LED is a valid name, but my space LED is not. Also, you are not allowed to use reserved keywords, so trying to name a variable char would not be allowed. We then need to initialize the variable, which is where we assign a value to it. We do that by typing equals 13 semicolon, which ends our statement. So this statement creates a variable named LED and sets it to an initial value of 13. Then, whenever we want to access this variable, just use the name LED. We can replace all other instances of 13 in our program with the variable LED. This new version of our program using a variable will run exactly the same as our old version. The advantage is that by using a variable, we can change which pin we want to use by changing only one line of code instead of 3. Additionally, we can change the value of the variable later in the code. At the end of the loop function, if I add LED equals 12 semicolon, what do you think will happen? This updates the variable by assigning it a new value, 12 in this case. If you were to upload this program to your Arduino, the LED would blink once and then stop. The first time through the loop, LED is 13, so you control the output of pin 13, which is what the LED is attached to. Then, on the second time through, LED is now 12, so you are trying to control a pin with nothing attached to it. I urge you to give this a try. Now, let's see how to print variables, which will be very helpful in the upcoming challenges for this section. Start a new Arduino program, and at the top, declare and define some variables. Int a equals 42, semicolon, char b equals open single quotation mark, g, close single quotation mark, semicolon. In setup, write serial.begin, open parentheses, 9600, close parentheses, semicolon. Then in loop, write serial.print, open parentheses, a, close parentheses, semicolon, followed by serial.println, open parentheses, b, close parentheses, semicolon, and then delay, open parentheses, 1000, close parentheses, semicolon. In the first line, we print the value of variable a, which is 42. We then immediately print b, which is g. Because we used print and then println, we should see 42g appear on one line. Wait for 1 second, and then 42g appear on the next line, and so on. Compile and run. Open the serial terminal to confirm that this is indeed what happens. I hope this helps you understand how to create and use variables in Arduino. Knowing how to manipulate variables and print them to the serial monitor will be an indispensable tool for the upcoming lectures and challenges.